Hey Year 7s, welcome back. We're actually going to go ahead and introduce algebra today. Now, algebra is quite a daunting topic, but it's actually really helpful doing the different topics we've already learned before. So, for example, working with percentages or working with statistics, that stuff can be made a lot easier using algebra. So that's what we're going to be doing today. It's on exercise 5A, which is on page 268 of your textbook. Now, before we get into using algebra, we've got to go ahead and try and make sure we understand the terminology in algebra, okay? So in algebra, we can use letters. Now, hopefully you already knew that, but we use letters to represent numbers. That's what algebra is all about, because what if I don't know a certain value? Then I can just give it a letter for now, and then we can work it out later. And those letters, we actually call pronumerals. Right? Pronumeral is just another way of saying the letters. So for example, A, B, C, D, blah, 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 whatever it is. But those pronumerals actually represent any number, as in any possible number in the world. We just don't know what it is yet. So if a pronumeral represents any number, it's called a variable. Okay? A variable. Now you might have seen this before as well. A times B in algebra, we write it as AB. So if there's nothing in between, you can see that if I zoom in, this section in the middle, there's no operation there. So normally in arithmetic, we will go minus or times or whatever it is. If there's nothing in the middle, that means it's actually a multiply. So AB actually means A times B. And in the other sense, A divided by B, we write as A over B, just like a fraction. Just like how 3 over 4 is the same as 3 divided by 4. Okay, so that fraction means that we don't have to use the multiply and divide symbol as much in algebra. So we don't actually use them at all. We still use plus and minus, but we don't use the multiply and the divide symbol. So those two things, those two notes, you should remember as we move on through these exercises. Okay, so a term, so another unfamiliar word, a term consists of numbers or pronumerals combine with a multiply or divide. Okay, so any letters, numbers that we're combining with a multiply divide. So not plus or minus, specifically multiply or divide. So for example, 5 over here, that's just a number by itself, that's a term. And x by itself, that's also a term. Now 9a, you know there's a 9 times a. So they're connected by a multiply, which means that 9a is also a term. Here, I've got 4 times x times y times z all divided by 3, which means that that is also one term here. ABC is also one term because A times B times C is connected by multiples. So ABC is also a term. Alright, a term with only numbers, so no pronumerals, is what we call a constant term. Apologies that I'm throwing so much terminology at you, but a constant term is literally any number. So for example, 6, that's a constant. 63, that's also a constant, but 63x is not a constant because now there's a pronumeral and there needs to be no pronumeral for it to be a constant term. So a constant term is literally only a number. Okay. Now, an expression consists of numbers and pronumerals combined with operations. Now, when I say combined, I mean we're using plus and minus. Now, I said before we don't really use divide and multiply symbols in algebra, but we actually use addition, and subtraction quite a bit. So, for example, in this first one over here, let's focus on that one. I've got two terms. I've got this term here, and I've got this term over here. Okay, I should really do that. There we go. I've got these two terms over here. Now we have to identify, well, are they constant terms? Well, I know that this one has an x there, that one has a yz there, so they're both not constant terms. But this together makes an expression. Okay, an expression. And the same idea applies over here. We've got to understand that we use, in terms of expressions, we're having an algebraic expression when we add or subtract different terms. So, next term we're looking at is coefficients. Okay, so we looked at terms, constant terms, expressions. Now we're looking at coefficients. So a coefficient is the number in front of a pronumeral. So for example, in the expression of 8x2y plus z, if I was to choose the this term over here, the coefficient of y is 2. Or if I choose this one over here, the coefficient of x is 8. So it's whatever number's in front of the pronumeral, okay? If there is no number in front, the coefficient is 1. And the reason being is, let's say I pick an actual number. Let's say I pick 4. Now, 4 is the same as 1 times 4. And the same idea applies in algebra. So if I have if I have z, that's actually the same as 1 times z. Now remember, we don't actually write the multiply symbol in algebra much, so it's just the same as 1z. So when there's nothing in front, the coefficient is 1. So in the case of this one over here, when I've got z by itself, the coefficient of that is actually just 1. Awesome, let's go ahead and put this into practice. So let's first state the individual terms in the expression of 3a plus b plus 13c. Now remember, we separate the terms by looking at the addition or subtraction. So in this case, I've got 3a, that's one term. I've got b, and I've also got, and I've also got 13c. Those are my 3 terms. Now, state the coefficient of each pronumeral in the expression that 3a plus b plus 13c. Now, I've got 3 pronumerals, of course. I've got a, I've got b, and I've got c. So, what are the coefficients? Well, if we look at a, the number in front is 3. So the coefficient is 3 for a. If I look at b, there's no number in front. Remember, if there's no number in front, we write a 1. Okay, and over here for C, I've got 13. So my coefficient for 13 is, for C, is 13. That's it. Now, this is where it gets a little bit more interesting. We can actually change worded problems by using algebra. So for the first one, I've got write an expression for each of the following where 5 is five more than k. So 5 more than k. If I was to replace k with a number, just for temporarily, let's call it 3 for now. 5 more than 3. I would write, well, 3 plus 5, because it's 5 more than 3. But I know we're using k instead, not 3. So I'm going to write k instead. So I'm going to go k plus 5. And that's it. I've got an expression there that tells me 5 more than k. Let's go ahead and do a similar step, except I'm not going to replace it with a number. So I've got 3 less than m. So I'm thinking, well, I got to start with m, and I got to take away 3, because it's 3 less than m. So I'm going to say m, take away 3. Too easy. Let's keep going. So the sum of a and b. So I'm thinking, well, the sum means plus, right? The sum means plus. So the sum of a and b is just a plus b. So it's a similar idea to what we're using in terms of just arithmetic, except we're using letters to replace the numbers. All right, this one over here, we have to write an expression for each of the following without using multiply or divide symbols. All right, so for A, P is halved, then 4 is added. So it says then 4 is added. So let's focus on the first half of the question. P is halved. So I'm going to write P. Now, if it's halved, another way of saying halved is divided by 2. So I'm going to write P over 2. So I'm not writing that because we don't use the divide symbols in algebra much. So I'm going to say P divided by 2, as in P over 2, and then 4 is added, so I'm going to write plus 4 here. Okay, so it's and then 4 is added, not to the P, but to the whole P being halved. So we write plus 4 at the end. Alright, next one. The sum of x and y is taken and then divided by 7. So the sum of x and y is taken and then divided. So let's ignore the then divided first. Let's focus on the sum of x and y. So remember, sum means plus. So I'm going to write x plus y. And then I'm thinking, well, and then divided by 7. So that means all of it is divided by 7. So instead of writing divided by 7 like that, I'm going to draw the line. Oops. I'm going to draw the line and then divide it by 7. And that's it. Hopefully that makes sense. Let me know if you have any questions.